Alright, so hi everyone, welcome to my YouTube channel CC of Election, and in this video we're talking about unit vector. So the unit vector is just a vector whose magnitude is exactly 1. So in the previous video we talked about the magnitude of a vector and we defined it and expressed it mathematically, and for the magnitude of a vector is just the scalar part of a vector, knowing that a vector has both magnitude and direction. So just the magnitude itself is the scalar part. So for a vector whose magnitude is exactly 1, that means this expression gives us a result of 1. Okay, so that is a unit vector. And so you see this expression here, we're using it in 2 dimensions. So this expression here, okay, of course this represents the magnitude of a vector, this is the vector. So for a vector which has magnitude and direction, if we divide that vector by the magnitude will cancel out the magnitude of this vector. What will be left is just the direction. Okay, of course when same value divides itself, the answer is 1. So if we divide a vector by its magnitude, the total magnitude of a vector will be 1. Just like saying we have magnitude here, and let me just use this as the direction. Let's say I, let's say that's the direction, and then we have this. So now this is the unit vector. This part is just the vector, okay, because this part contains the magnitude or the direction and then the magnitude, but this part is just the magnitude. So once you divide like this, the magnitude will cancel out the magnitude, and of course the value there will be 1, because anything, same thing divide same thing, will give you 1 as the answer. So the magnitude will cancel out the magnitude, and what will be left is just the direction. Okay, just the direction that will be left. So the thing is, since the definition of unit vector just means a vector whose magnitude is 1, that means we have to give this as a mathematical expression. So of course this part, this top is the same as this. Okay, is the same as this. So the vector which has magnitude and direction divided by the magnitude, so that the magnitude will cancel out the magnitude, and what to be left is the direction with a magnitude of exactly 1. So so with that, take all this out. So with that, this is the formula for unit vector. Okay, so this is formula for unit vector, and this is the symbol used for its unit vector. Now, with what we just talked about, that what we'll have left is the direction. That means most times the unit vector is used as direction. Look at what I have in my rough here. Yeah, the unit vector can be used as an indicator of direction in space. Okay, so move it over to the other part. Now put that here. Okay, so it's used, unit vector can be used as indicator of direction in space, and we understand why, because what we have left is just, when we divide, when this division is done, what we have left is just direction. The magnitude will be exactly 1, which is 1. So alright, now with that being said, let's work an example. Okay, let's try out an example with that. Okay, so example, okay, so we have it here. Okay, I should move this guy down. Yeah, there we have it. Sorry. Okay, so the example is this. We are trying to read what's happening, bro. Okay, better. Yeah, exactly. Now the example is this: a vector is given as a equals this. So this is the vector, right? This is a vector. This is a vector. Now, having this as a vector, what we have to calculate is the scalar component of the vector in x and y direction, then the length of the vector, and then the units in the direction of a. Hey, that is correctly with where are you? The unit vector in the direction of a. The unit vector, yeah, there should be vector here. Unit vector in the direction of a. Good. Now, so let's go. So what we'll do first is to get this value here. Excuse me. Bring this up. All right. Good. Now let's solve. So solution. So first thing, we take our vector. So our vector is this. Which is x. Vector a equals minus x, okay, and in the direction of x, 5 minus in y direction plus 2 plus z. Okay, so what happens next is this. The first question is the scalar component of vector a in the x and y direction. So for scalar components of a vector is the magnitude of the vector, okay, without the direction. So in the x, y, and z direction, x direction, this is the direction, right? Now what is the magnitude? 5. So that magnitude is a scalar component. That's just it. So I think is there any need to solve the a, because okay, let's just write it. Because for a, the scalar component in the x direction equals minus 5. Sorry, not just 5, minus 5. Okay, because we have a negative sign here, so it's minus 5, not just 5. Okay, then in the y direction, I think I should write it this way: ax, then ay will be negative 3x plus 2, then az, I don't know how you call it in your side, az, whichever one, or you know what we are talking about, so thank you very much. What do we have here? What's the value here? 1. Okay, so 1. Okay, invisible 1. So that's the answer for A. Simple as that. That's the answer for the A part. Then the B part is this. Let's check the question. The length of the vector. Good. Now the length of a vector, remember the definition, what we defined in last video, what we talked about magnitude of a vector. We said that the magnitude of a vector is its size or length. So when we are asked to calculate the length of the vector, we are just, the thing is, what is the magnitude? And for magnitude, we have the formula as magnitude of a vector, which is this, equals this component ax squared plus ay squared plus az, if I was still on the screen, az squared. Okay, all this correct. Now the next is just to put in the values. So we already have the ax is this, ay is this, and az like that. So just so modulus e equals, for this is -5. Of course that minus sign will have like no effects on this. Then okay, 3x plus 2. I think I should just remove this minus sign. Yes, I should just remove the minus sign by doing this. To remove that minus sign, it just means here will be -3 and multiply everything inside here. Multiply everything inside here with the minus sign. Okay, so that will make here -2 all squared. Yeah, better. Then of course 1 squared and square root of them all. Okay, so this will result in a, because this, I shouldn't have done that now, but here with 25 plus, and these will be -3x minus 2 -3x minus 2 and then plus 1. So next we'll have next we'll have 25 plus, this will give us 9x squared, and this will give us 6x, and then another 6x positive, and then plus 4 plus 1. Okay, so this plus this, that's 30. But I'll put the 9x squared first, and this plus this is 12x, so I'll put that next. So we'll have 9x squared plus 12x plus 30. So being that we have x there, an unknown, I'm not going to simplify for that. I'll leave it like this. Okay, so this is it. Now the c part, this is the magnitude of the vector. Then the c part of the equation talks about the unit vector. Okay, so let's look for unit vector. So just go with the formula, and knowing that our formula is for unit vector, a is the vector divided by the magnitude of the vector. I already have the vector, so this equals so let's just copy the values because we already have the vector. The magnitude of the vector, we already have it here, which is this. So we can just copy it over, and then paste it here. Done with that, balance a bit. Yeah. So that's the magnitude of the vector. Then the vector itself is this. This is the vector. So subs, you make this smaller. Alright, so yeah, that's it. And we can stop there as the answer. Okay, that's it. We can stop here. So yeah, this is it. So this is just unit vector and the example that has to do with unit vector and magnitudes of a vector. And this will be all for this video. And if you have any question, leave it in the comment section, and subscribe, share, and see you in the next video. Thanks for watching, and bye for now. Thank you.